Okay, we're continuing with proportional relationships and talking about how to tell if relationships are proportional from looking at their graphs and equations. So a graph needs to have two things to be proportional. It needs to be a straight line, and it needs to go through the origin, which we know is the point 0, 0. So over here we see this one qualifies. It's a straight line, goes through the origin of 0, 0. And remember, if a relationship is proportional, we can find the constant of proportionality, otherwise known as k, by doing the y divided by the x. We also know that the horizontal line on a coordinate plane is the x-axis and the vertical line is the y-axis. So here's a point on our graph right here that is the point 1, 2 over and 3. So this is my x, this is my y. If I wanted to find the constant of proportionality from this line, I would do y, which is 3 over 2. This graph over here is not a proportional relationship because it does not go through 0, 0. All right, we're going to try some on our own. We're going to take these tables and make graphs from them, starting with this taco problem that we saw on our last notes. We have our x-axis, we have our y-axis, they meet at 0, 0. I know my first set of numbers are the x's, my second set are the y's in the table, so these are going to be my tacos down here where the x-axis is, and my cost over here where my y-axis is. I'm going to count by ones for number of tacos. Remember, it has to be consistent, and I'll count by dollars going up. You just can't skip any or leave any out. It has to be consistent. So 0 tacos is $0, 1 taco is $1.50, 2 tacos is $3, 3 tacos is $4.50, and 4 tacos is $6. We're going to connect these, and lucky for us, it is a straight line, and it goes through 0, 0. So we can say, yes, this is a proportional relationship. Is the relationship proportional? And if yes, what is the constant of proportionality? The constant of proportionality is always where always where x is 1, because it's how much for 1. So it's this point right here, which is the point 1, 150. So we're going to do x and y. For our points here, we're going to do y over x, which is $1.50 over 1. Which is just $1.50. I could have used any point on here. If I did 6 divided by 4, I would still get $1.50. If I did 450 divided by 3, I would still get $1.50. All right, let's try the rides. Remember, the first set is x, the second set is y. Whether it's a horizontal or a vertical table, the first set is always x. This is always the x-axis. This is always the y-axis. So this is going to be rides down here and cost over here. My rides are going to be 1, 2, 3, 4 for my table. Then I've got to go up to $28. What do I have? 1, 2, 3, 4. I better count by 5. So 5, and then 10, 15, 20, 25, $30. So I have... if I go on 0 rides at the fair, that's still $20, right? Because it's $20 to get in. So it's definitely not going to be 0, 0. So we're going to start with 1 ride is $22. 2 rides is $24. 3 rides is $26. 4 rides is $28. 0 rides, just getting into the fair, is $20. So this is not a proportional relationship because it doesn't go through 0, 0, so there's not a constant of proportionality. All right, let's go down here to equations. So equations of proportional relationships can be written in the form y equals kx, where k is the constant of proportionality. So it should look like this. An equation like this, we could look at and automatically know the constant of proportionality is 8. But if you look at the one over here, this is not a proportional relationship because it's not written in the form y equals kx. It actually has this part added on, which makes it not qualify for that form. So to look at that even more closely, let's try to make an equation from the taco problem and the fair problem up above. So for the tacos, I could write an equation by saying that the cost is $1.50 times the number of tacos. And my equation for the fare would have to be that the cost is the number of rides times $2 plus the $20 it costs to get in. So you can see the equation on the left is in the form y equals kx, and we know that's proportional because the graph is proportional, the table is proportional, and now the equation shows a proportional relationship. And the one on the right, as expected, is not proportional because we couldn't write it in the form y equals kx. We also know that in the table up here, the ratios are not equal, and we know that in the graph it doesn't go through 0, 0. All right, thanks for watching.